This video is a set of instructions on how to draw an altitude of a triangle.
So first off, we're going to define what exactly an altitude of a triangle is. And I have a definition here in this card. It's a lot of words and we'll kind of go through it step by step, but an altitude of a triangle is a line segment that is perpendicular to a given base of the triangle, and it connects the given base or an extension of that given base to the opposite vertex. So, for example, if I draw a triangle here, and notice it says, talks about a given base. I'm going to designate this as my base. Okay. Then I want a line segment perpendicular to this, and I also want it to connect this base to the opposite vertex. So the opposite, or the vertex that's opposite to this base, is this one here. And so we want a line segment from this point down to this base, and it needs to be perpendicular, or a 90-degree angle between the segment we draw and the base. So I'm going to use my note card actually to show that, because this corner will serve as my 90-degree angle. And so I can slide it on the base until it hits this vertex. And I can draw that line. That is the altitude of the triangle that goes with this base. So why are we interested in drawing an altitude? Because we need it to compute the area of a triangle. So the area of a triangle we found out was 1/2 base times height. And so in this particular simple drawing here, the length of this base here would be our B, and then we could use our ruler to measure the length of this altitude, which I have labeled H, and whatever that length is, that would be what we would fill in for the variable H, and I should put this 90-degree angle here. So this is a very simple example. I'm going to show you first some examples on dot paper, which are the easiest case, and then we'll look at some that are just on plain paper, where we have to actually use a note card like I showed you here. So first we'll look here. So on this dot paper, and I have the definition up here so you can refer to it, I have 3 triangles here. And so we're looking at these gray shaded triangles. Notice on this one I have a dark bolded base. That is the base that we're going to be interested in coming up with an altitude for, and then measuring that altitude to get our H. And so this base here, I'll label B. And from our dots we can tell that its length is 1, 2, 3, 4 intervals, so 4. And then we'll need the length of H to compute this. So how did I get this H here? So if we look at our definition here, we need a line segment that's perpendicular to our given base or an extension of the base. So this base, my first step was to extend it here, right along here, and extend it far enough so that when we look at this opposite vertex here, if you can think about dropping a stone, if this is our ground, our horizontal ground, we dropped a stone from here, it would go straight down, and where it hits the ground level, that really is kind of an idea of what our altitude would look like. So for this one, since the dots are at 90 degrees, it's kind of our grid, that makes this very easy. So if I extend this base so that it comes underneath this opposite vertex here, and we draw the line straight down to the base, by the way these dots are arranged, we know this has to be a 90-degree angle. So then we can measure this altitude, or H, to get 1, 2, 3, 4. So our H is 4. And so then our area of this triangle would be 1/2 base times height. So in this case it's 1/2 times our base is 4 and our height is 4. So 1/2 of 16 is 8 square units. Okay.
Here are some other examples of altitudes on dot paper. In each case, they're highlighted in pink.
Okay, so now let's go on to the case where we have triangles that are not drawn on dot paper or any kind of grid. And so we don't know what is perpendicular without actually using something like a note card that has a 90-degree angle to come up with that. So what I did was I have the same triangle and I've drawn it on this paper, copies of it, and we're going to look at each base and find the height or the altitude that goes with each base, draw that, and then we're going to compare the areas we get in 3 different ways. So every triangle has 3 different bases or sides, and each of those bases or sides has a different altitude. And so we have to make sure that we match the correct altitude or height with the given base. So let's start out with this triangle here. So I have this one, this side here is bolded. So what I'm going to do is rotate my paper so that this base here is my horizontal. Okay, so that's at the bottom. And if I look at this, my vertex that's opposite this base here, so this is my base. The vertex that's opposite this base is this vertex here. I'm going to circle it. Okay, so if I'm thinking about a stone dropping from here to the ground, it's not going to go this way. It's going to go straight down like this. So I know that my altitude will be somewhere over here. So that tells me I have to extend my base in this case so that I can see where my altitude will hit it. So I'm going to use a ruler here so I get an accurate line. So let's see, I'm going to put that in blue and then I'll extend this base. I'm going to use a dotted line for this because when we go to measure our base, we don't want to mistakenly measure this extension as well. So that's my extension of my base here. Extension of the base. But this is my actual base measurement that I'll use for my area calculation here. Okay, so now we're going to use the note card. And again, I have one corner that I'm going to say that's my 90-degree angle. And so what we want to do is slide the card along this base, or the extension of the base, and watch this leading edge here. When it hits this opposite vertex, we know that we have our location for our altitude. So I'm sliding it along. And it looks like that. So I want to make sure that this is still lined up here and it's hitting the opposite vertex there. So I'll go ahead and draw my altitude. I'm going to label it H and make sure I draw my 90-degree angle in there. Okay, so this is my altitude that goes with this particular base. And so now we can do our area calculation here. So I have a ruler and I'm just going to use centimeters. So our base dimension looks like it's about 10.6 or so. So I'll write that down. And our height dimension here, and it looks like that is about 6.8. Okay, so our area would be, let me calculate that. So 1/2 times 10.6 times 6.8, and I get 36.04. We'll use 36.0. So that was from 1/2 10.6 times 6.8. we got our area there.
That concludes this video. I hope it's been helpful.